Remember, Global Mantics went into the business of selling Star Wars memorabilia here. So we're going to rearrange our network a little bit. Here I have my inside PC in my trusted zone and the web server in my untrusted zone. NAT comes in to save the day as the solution. So the private addresses, that RFC 1918 space, when we try to route that out to the public internet is explicitly designed to say, I am not routing any message to the destination addresses of those three networks. Period. End of conversation. Not happening. So the public internet is going to drop messages when we route them to any one of these three address spaces, which is perfect, which means that we can reuse those address spaces all over the place. But if we want to talk out to the public internet, we need to do something more. So here's the essential how NAT works. On the inside, we have this private network. We have a message coming from our PC with a source IP address of 10.0.0.1. When we hit that NAT boundary, we need to change that IP address from a private address to a public address before we send it out on the public network. Here I'm talking about the tubes. And we're going to then reply to that message. The internet will reply to that message. It's going to have a destination IP address now of the 198.168.100.10 address. That gets sent back to our NAT device. The NAT device would then replace that address with the private address and then forward the message on. Without that NAT happening, that address change, what would happen is our message would get lost out on the public internet. We'd never see it again. How is it doing this? Well, NAT is explicitly manipulating the packet header, and it is explicitly manipulating the source and destination IP addresses. NAT is designed to manipulate either one, source or destination, or both. Additionally, when we're talking about port address translation, we need to bring in the TCP segment header and see that we're actually manipulating the source and destination port numbers as well in certain occasions, or at least with network address translation, we have the ability to manipulate these ports. What's relevant for NAT here is the source IP address and destination IP address of the packet, and the source and destination port number of the segment. When we put these together, we call them sockets. So we have source IP address : source port number, and destination IP address : destination port number. So the socket is what we're going to be recording and manipulating and working with when we are doing NAT. In order to understand how NAT operates now, we need to understand the difference between local and global areas of our network. Now, when we talked about how the firewall operates, we talked about the inside trusted area and the outside untrusted area. And typically with NAT, these correlate, that our local network is affiliated with our inside trusted network, and that our global network is affiliated with the outside and untrusted network. Is this always true? No, this is not always true. The idea here with NAT is that we need to identify a local area for the packet to exist and a global area for the packet to exist. And what we'll do is we will record information of the packet when it's in the local network. We'll manipulate the packet header and then send it over to the global network to get sent out, and then we'll reverse the process when it comes back. So local and global are identifying which side of the NAT device that we are talking about. This will prove useful for us because in order to apply NAT, when we're doing dynamic NAT, we need to really have a good understanding of local versus global. Now we're going to start simple here. We're just going to have one single user in our house trying to reach a website out on the public internet. So they're going to try to browse to 203.0.